So let's welcome Mr. Rajesh.
Can you see my slides?
Yes, sir, it's visible.
Good evening, everyone. I have been given a task to talk about the modernization of transmission and distribution system in India. First of all, I would like to thank Almighty, my family, my mentors, and finally the EPR who invited me here to talk about the technical aspects. When I say the technical aspects, it always starts with some fundamentals. And for power system, that is transmission distribution system, there are three basic parameters we usually come across: voltage, current, and frequency. In TND systems, there are five major sectors, subsectors in fact. It starts with planning and specification, then procurement and inspections, commissioning and testings, finally the maintenance and condition monitoring. In all these five sectors I have already mentioned, there is an important role of modernization of system. We have many terms available with us. We have information and communication technology. We have phase measurement unit. We have IED, intelligent electronics devices, smart meters, IoT, ADMS, AMI, ADN, battery energy storage systems. We have digital twin. We have AIML. We have control switching and synchronizing switching systems we have. Coming to the point, why this modernization is required? Because we are living in an era, it is very difficult to afford any kind of outages. We have to maintain the reliability and availability. We have to take care of the efficiency of our systems. We have to take care of the economic growth. We have to understand the invention of electric vehicle and their charging stations and their requirement. We have to we have to equally take care of the renewable energy integration in my grid. I have to take care of the automatic fault detection, that is the protection and the safety. Last but not the least, at the same time, I have to empower my consumer. I have to give consumer a tool who can provide necessary information and facilitate them in getting many works done online. We have to do the efficient use of available resources and assets we have. We have to reduce the breakdown, downtime, availability we have to increase the reliability. Finally, we have to do the effective load management. All these things finally compel me to go with the modernization. I am here to share the 30 years of experience of myself in the power sector. 30 years ago, there was this power system grid was quite simple. There was one generating plant. Then step-up transformer was there, then transmission line, sub-transmission line, distribution system. Then it was finally the power was coming to my home. This is the power transformer we usually come across, who can give power up to 300 MVA, 500 MVA, 160 MVA, 100 MVA, depends. This picture is very important picture so far. Conventional versus modern grid is concerned. If you look at here, there are distributed energy sources are there. There are renewable powers have already come into the grid. Even at your rooftop, you are generating. The consumers are not consumer. They are consumers. We have to take care of all these things. When these things have become the part of my grid, I have to look into some system that can take care of all these things. What is smart grid? In fact, it gives power to my consumers. It makes my system efficient. It enhances my availability and reliability. It enhances the reliability of my systems. It enhances the protection and the safety. This was the conventional system where there was one control room building was there. There was relay and control panels were there in the control room. In the substation, in the yard, there were equipment installed. And these all equipments were communicating to my control room relay and control panel through control cables. Gone are days. Now this has been replaced by this electronics bay level modernization. Merger units are there, process bus are there. We are saving the cables, control cables. We are enhancing the reliability. We are moving towards smart system. This is another level, this one. This is a total overview of digital substation we usually have. We have merging units, we have process bus, we have IEDs with us, we have monitoring systems. It's the actual picture where all merging units are installed in my switchyard with CT and PT. Coming to the reasons for doing all these things. When I am using the merging units, it reduces my cabling. When it is reducing the cabling, it reduces the risk involved. There is no need for supervision cable at all. This is the future of my digitalization. The many countries, especially Russia, have already produced that optical CT and PT ICT instrument transformers. With invent of that technology, my system is going to be 100% smart, digital. It will increase my safety and reliability. My performance will be increased. There will be a reduction in the maintenance and manpower requirement. Reduction in the outages because of shutdown. And there will be some self-diagnostic system will be there. Apart from that, we are using some online equipments to take care of my equipments that attribute to outages and that affects my availability and reliability of the systems. We have online DJ systems. We are using infrared cameras to pinpoint the hotspot before that hotspot convert into any major problem or outages. We have distributed temperature sensors for my big power cables in the network that keep on sending me signals about hotspot in the cables. I have assets lifecycle management systems where key indexes are given to each equipment based on their importance. And we are maintaining it with the help of technologies available. We have online PD sensors for my power cables. This is the step towards modernization. I can detect the partial discharge that may lead to failure of my cable, and that failure of my cable lead to outages, breakdown, can be very well predicted by all these online systems. We have OPGW wire for transmission systems. We can easily transfer the data, and because of that data, my relays at both end, sending and remote end, can communicate. There is no delay at all during some fault in the systems. Both hand will trip simultaneously. These are the changes we have seen in last decades. My distance protection have been converted to current differential relay. In the absence of any problem, in the absence of availability of fiber optics, it will work as a distance protection. These are the changes we have seen. These are the major benefits I have already explained. It improves the reliability, availability. It improves my efficiency. It helps in economic growth. I can integrate renewable power. I can easily detect the automatic detection of fault protection safety. It also empower my consumers. And when I say digital substation, it also helped me to reduce the footprint. It enhanced my safety. It helped me to do the embedded diagnostics. We can do the energy optimizations. We can reduce the large numbers of cable required, control cables. It is not required. And for distribution systems, it helped me to do the outage management systems. I can pinpoint where the problem is, what were the reasons of that fault, and after fault has happened, what to do, how to fix it, and approximately time duration required to restore the faulty systems. And that is possible with some technologies like GIS, CIS, consumers information systems, automated metering infrastructures, mobile workforce management systems, and SCADA. This is the overview of outage management system in my distribution system. And when I talk about all these things, it always comes with challenges. And the very big challenges for doing modernization and digitalization of my systems is infrastructure investment. We need approval of state regulatory commissions because it has direct impact on my tariff. I have to take care of climate change and other.
Mr. Rajesh, I'm sorry to interrupt you. Could you please continue your individual submission in a minute? Because
Yes.
you're short of time.
Yes. Last but not the least, my concern is the cybersecurity. I have another issues like regulation standard policies. I will be facing problems of skills and knowledge. Equipment compatibility, operationability will be issue. We have to address all these challenges, and we have to make our system smart, modern, and we have to adopt technologies available. Thank you.